Okay, so now I'm going to post this.
Oh, okay.
Okay, it's recording now.
All right. Okay. So how many people have questions? Let's start from there. Otherwise, we can just go to. We can just look at the.
Hello, sir. Dr. Arinze.
Yes.
I have a question, and it's on the finding the shape of array.
Finding the shape of array.
Yes, getting the shapes. Yes. An example there, we add 1, 2, 3, 4, 5, 6 in a list.
Which class? Which class was it?
Third class, sir.
The third class.
Yes.
The third class with Mr. Gaston.
Yes, sir.
Okay. Okay, finding the shape of. I will have to just put your question in writing and refer to the class.
Okay.
If you can also refer to, just make it very fast, the path in Jupyter Notebook that you are having issue. So for instance, you can see that these things are marked with in on line 12, line 13, and so forth, okay? In and out. So if you can just also mention the section in the email, we can very quickly identify where the issue is and reply to you, okay?
Okay, sir.
All right. Who else had, who sent, did somebody send questions? Let me see. So like for now, so like for instance, if you have questions, send them as email and then we'll attend to them. We'll look at them before the class actually starts. Look at them quickly and then move on to what we have for that day. I think that would be best, or better still, reply to you directly in the forum and everybody can benefit from the response. I think that's how we'll do it. We'll reply to you in the forum as much as possible in a way that it's clear. If it's not clear within the forum, then we'll bring it to the class. But if it's clear and there are no more questions, then everybody can move forward. And sometimes your colleagues may actually have the answer to the question. So it may be that maybe a line or so in a code that you got confused with, and someone else can actually answer that question for you. So that's what I've discussed with Mr. Gaston as well. We have to set up a forum for our class where we can be asking questions and getting answers quickly. Right. So let's look at. Oh, this is still recording. Let's look at what we did for the first assignment. This is section 4. If I can download your first assignment. Okay. So now, I want to be sure that everybody has their computers and everybody's ready. Right? Do we all have, if you go to Basecamp, you can actually download this section 4. You would have received the email. So let's go to Basecamp, download this section 4, and then let's look at the let's quickly look at the solutions to the assignment, and then we can move on to section 4. Okay. So let me just bring up what we did. Just a second. Let me. Okay. Okay. So in the let's bring up the what we had for our first assignment. So the first part of this assignment wanted you to just do a quick just a quick test of what we've done so far, and just basically to test your understanding. Okay. The first part can be done in any way. So what is the value of, okay, the first part, write an equation that uses these to achieve that result. So you can even do 415 plus 0.43 for addition. You can have for subtraction, you can let's say have 418, for instance, minus 3 will give you 418.43 minus 3 will give you 415.43. So this one would kind of vary based on various answers. I will have a look, but it's not going to be too difficult for any one of us. So just a combination of various things. So for instance, you can add 60 plus a different number raised to power a different. So different ways. I'll look at what you've done. Different ways we can achieve this result in different ways. For the second part, what is the value of this expression? So let's look at that. Again, you can actually get the answer before actually typing in the code. So we introduced the sequence of operation. So for instance, we know that we'll deal with the bracket first. So 6 plus 5 is obviously 11. Then 4 times that will give us the answer, which would be 44. For the second part, multiplication comes before addition. So, okay, let me just type them out. So we can have 4 times, I don't know if this will delay our other class, but who was in, let me, because these parts were obviously very easy. Is there anyone in the class that was a bit confused about these easier parts? I'd like to know. If you have any question about these easier sections. Okay, let's continue. The next one is 4 times 6 plus 5. So we can achieve that with just typing them in there. 4 times 6 plus 5. The main takeaway from this is really the order. So we know that multiplication comes before addition. So we expect to have 29 as the answer. Also, again, multiplication comes before addition for the third one. I'm just going to copy this, make a new cell. So 6 times 5 is 30 plus 4, 34. What is the type of this result? What is the type of expression for this 3 plus 1.5 plus 4? Because we have 1.5 in there, then it makes it a floating point number. So I can add that answer is floating point number. What would you use to find a number square root as well as its square? So just an example of how you can perform square roots and also do to also square a number. So a quick example, again, there is no, we just want to know, we just want for here, correct answer of a square root. It was not specific, so we can say 81, for instance. Square root of 81. I wish I can see your faces out. I'll be pointing hands by now. When I was lecturing in the university, if it looks like someone was not paying attention, the person gets to answer the question. Okay, but I suppose everybody's paying attention. Okay. Okay. I'm just looking at some messages that was okay. So yes, for challenges, yes, we just send an email and it's possible to either go through that challenge in the class or go through it in the discussion. We'll start off with the discussion board and try to sort it out there so that the classes can really be for the classes, or one-on-one solution. Back and forth, you ask this, we try to answer you and try to really sort out your case. Okay, just send us the email like we said and we'll sort it out. So in this answer here, we just wanted a result of a square root. So it could be 100, it could be 81, it could be 64, etc. So for here, the square root using the 0.5 that we discussed about in the class. So something raised to power. Remember, this is raised to power 0.5 will give us 9. And for a square, we want to raise it to power 2. So the difference here is raised to power 0.5. And for the next part, it's raised to power 2. So we expect to see this part and this part. But the numbers that you choose can vary because we didn't specify any particular number for you. Okay. Given that string, give an index that contains or returns only E. Okay, so how will you pick only E from this expression? We discussed indexing in class, and we know that Python starts indexing at 0. So if we, for our S, we can, the first index, which is index 0, will give us H. So it means that the second index, which is index 1, will give us the E. Okay. So that is that for the answer. And again, this these are literally in the notebook for that class. So it's almost a giveaway, but it's just to help your understanding of these basic terms before they start getting too complicated. The next part asked us to reverse the string. Reversing string, again, is what we covered. So we can reverse the string by reversing the index from the last one. So starting from here, the last one minus 1, we can count backwards. We can print backwards. So we covered that all rows, all columns from the back. So if S is hello, reverse the index using slicing. So we want to see basically Ole, O-L-L-E-H. And this is the way that we can achieve it. Given the string hello again, give two methods of producing the letter O using index. So I just gave out the first answer there. So how can we get O? How can we get O? There are various ways we can extract O. O is obviously the last one. And we know that if we want the last one, then we can use the -1 to start. We can place the index of -1 to extract the last item or last character of that string. So we can do this to get that O. Let's see. Okay. Let's see what -2. As you can see, -2 will give us L. -3 will, so we can count backwards from there. -3 will give us the second L. -4 will give us E, and -5 will obviously give us. So the first part to extract our O is -1, but there's also another part, and there's also a second way of getting O. O is index 0, 1, 2, 3, 4. Our O occurs, is the 5th index with number 4, obviously, because Python starts from 0 indexing. So we can also extract that same O by passing 4. So that's again H will be 0, E will be 1, L will be 2, second L will be 3, and this 0 will be 4. So we can extract the same O with that. Okay. There are, for lists, we can build our lists in various ways. We want just to see 2 ways of building that list, just list of zeros. We remember that in Python we can, which is quite interesting because we can't do this in many other languages. You can just multiply things and it will replicate. In other languages, you have to use a different function if you want to replicate items. But in Python, you can simply just multiply. Let's say this our list of 0 now. It's in square brackets, so it's our list. And then we can literally just multiply it by 3. And we will have 3 zeros. Okay, so we covered that. We saw how we can just use multiplication to replicate things. Secondly is the answer there. You can literally build that list by assigning it to something like L1, and then L1 is a list of 0, 0, 0. And then you can print out L1. So 2 ways of achieving this. Either you go straight with it and assign it to something, or you can just multiply it by 3 or any number, the number of times that it occurred. So basically the answer, we want to see how you achieve or build this list basically. Okay, so those are the 2 ways that we can build them. If anything gets confusing, 7. So let me see. Okay, so as much as possible, we'll try to answer questions, but there are so many people, so it may not be possible to have regular one-on-one with each and every one of you. That's why we want to use a discussion board as much as possible, where you can ask your question and then we try to answer it there. Because there are, as you know, there are other classes and there are also other things that need to be done. But for now, send us the emails detailing issues that you are having, and we'll try to, as much as possible, attend to you. Another part of this learning is, like one of you pointed out, practice, practice, and practice again. If you keep practicing, you will get better and better and better by the day. You will be the one answering other people's questions, okay? So that's just an encouragement. The more you practice, the more you get better at it. Just practice, because that's why we're using these notebooks. You can literally run the cells directly. You can delete something and it wouldn't work, and you see why something didn't work. You can add something to see how it works and, you know, enforce your understanding. So practice, don't just leave it till the upper week. Practice, practice, and practice again. Okay. So this question asks us to reassign hello in this nested list to say goodbye. Okay. So this, we want to reassign this part with goodbye. That's all. Okay. I don't know if, I hope it was clear. Just this part. Reassign this hello here with the string goodbye. So how do you reassign this hello? You need to find out what the index is. So let's start from there. We called it list 3. Okay, so we know that, let's walk through this gently to see how it works. So list 3, let's start with 0. Okay, what is the first item there? It gives us 1. Yeah, so this is the very first item in that list. Let's see what 1 is. This is the second item. Let's see what 2 is. And this is the third item, right? So we have a list in a list. In this L3 list, the third item, or the second index, is this second list here. So how do we now get out this hello now? This string part of this sublist, kind of. So we have to pass another index for this second list here. Okay, so let me make another cell. So we've seen the result of this. So let's extract that one by passing another list. We want to extract content from here now. So let's see what the first item is. We should get 3. Oops. Okay. The first object is, sorry. My list is called list 3, sorry. So the first item of my list 3, of this second list, is this 3 here. The second one, which is 1, is 4. So the third item, which is the second index, should bring out this hello for us. So I have challenge with the list, nested list to post. Okay, so the students with some challenge with lists, I hope you are at least listening to this part, yeah, about this net, because this is like a nested list. This is list in a list. Okay, and this is how, I hope it's getting clearer. So we've been able to take our list. This is our list. We've seen how we can extract this sub list. Okay, great. The student said it's clear. That's great. Awesome. So that's good to know. You can see why it's good to actually be in the class than just watching the video. Okay. So that's how we can get this hello. Now that we've gotten that hello, what do we then do? The question says that we should reassign goodbye to it. So we now know the indices of our list. Okay, so we can take this our indices that helped us extract hello, and we can reassign. We can then reassign goodbye, for instance, to it. Goodbye. Okay. And then when we call our list again, we can see that we have reassigned our list with goodbye. Okay, so I hope that is clear. First of all, find the index of the nested list and then reassign the item to that list. The next item is to sort the list. Okay, and there are various ways that we can achieve this. We saw the sort method earlier on in our class. So let's use that to, let me make another. So our list 4, this is our list, by the way. And then we can call the method sort. So if you type dot and use your shift and tab, we can see more information about that list. But we know that we can call, excuse me, we know that we can call the sort method on our list to actually help us sort the list. So sorry. 4. So we can call the sort method to sort that list, and we will have it sorted in ascending order. We can also use the sorted. Now, as usual, we have to get used to reading documentations. So what did I just do? I placed my cursor in between the brackets, and I did shift and tab to see other things I may be able to do. So I can actually reverse that order, but reverse is false. If I set it to true, then I can reverse that order from what it is now to start off with 6, for instance. So that's one way that we can do that. We can call the sort method. We can also use sorted, which is a function that returns a new list containing all items from the iterable in ascending order. So this is another function that we can use to sort our lists. I'm sure you're getting familiar with how it works, especially Jupyter, that you can pass a function. So this is a function. A function will normally light up green. So if I add something now, it turns black. If I delete the W, it's green. So that tells you it's a function or method in Python. And then I can, in between the brackets, use shift and tab to see more details. If you're using something like PyCharm, you have another section in the PyCharm interface where you can easily see, or your Spider. There's another IDE called Spider where you can easily see Python. So this is another Python IDE where you can easily see the types of what you are working with. Okay. So back to the results. So sorted list 4. And we have the same result. But we did this, we covered this one. So you should have or get the right answer. Okay, using keys and indexing, grab hello from the following dictionaries. Okay. So dictionaries are key value pairs, as we explained in the lecture. So this is the key and this is the value, separated by a colon. Our dictionary is called D, and we want to grab that value. So you simply call the key and the value will come out, right? You put in the key. So if we pass the key, the key is simple key. Yeah, simple underscore key. Oops. Simple underscore key. So if you call the key, the value is expected to be returned. Okay. Now we have another instance of nesting. In this case, we have a dictionary within another dictionary, a key value pair within another key value pair. So the value for this K1 is this, as you can see. So let's see how it looks like. So again, it's D, and let's see what D here is. So K1 has the value K2 and hello, and K2 has this as its value. So let's grab them one after the other so that we take them one after the other and then get to our hello. I'll make another cell. So let's take key 1, for instance. If we take key 1, K1, as we said, K1 has this value as its, K1 has that dictionary as its value. So, and then we can then pass K2, because K2 is the key that has hello as its value. So let's make another cell for clarity. So if we now pass D of K1, D of K1, which will give us this, and we take K2, we are expected to get this result here, that's hello. Okay. Now, there is even another another interesting part. We want to grab hello again in this deep nested dictionary. But again, if we take them one after the other, excuse me, you can find out that it's not as deep as it looks. So first of all, K1 has all that as its value. Nested key within this has all that as its value as well. Okay, so when we start taking them one after the other, you can get to hello. So let's start one after the other. Let's look at what our dictionary looks like first of all. Again, we have K1, whose value is all these other ones. It's a list, as you can see from the square brackets, but that list also contains a dictionary of this one. So this second key here has another list as its value. Okay, so what is K1? Let's start from there. D of K1 returns that for us. That one is clear enough. Now we know that this is a list, right? Let's see what the first element of this our list will give us, because we want to get to this guy here, this hello. So let's see what I'm just going to copy this one here. Okay, so this is a list, as you know, because of the square bracket. So let's try to extract something from that list. Let's see what the first element is. This is the first element of that our list. Okay, so that our list contains this dictionary, and it's actually the only thing there, because it only has one element. It doesn't have this list only. It's just a list of one item. Okay, so the first and only element of that list is this dictionary here. Again, we know dictionary because of the curly bracket, and we know list because of the square bracket. Okay, so if you get through this point, then you can manipulate anything in terms of lists and dictionaries in Python. Okay, let's continue. So this our dictionary result has this. So this key here has this list as its value, right? So we want to extract this key, next key, and we should see this value here. Okay. So we want to extract this list, this key here. We will pass this key, and we expected to see this value because this key has this list as its value, right? Okay, so let's keep going down. So we want to pass this next key here. So let's pass that. Next underscore key. Okay, it returns that list for us. We know it's a list because of the square bracket. Okay, so let's continue. This list here, as we can see, has two items separated by this comma. Okay, let's check it and be sure. Let's make another cell. Okay, we can see that it has two items anyways. But okay, the first item is this thing. This is deep, and the second item, index 1, is another list that has hello. Okay, so we've managed to extract the list of hello. Okay, but it's still a list. It's not yet the string itself. This is still a list. this list contains only one item, which is this string here, this hello string. So let's finally extract that one item. Let's make another cell. Let's finally extract the one and only item in that list, which finally gives us hello. Okay. So I hope that is clear. If you can do that one, then you can also do this one. It's just following the same logic, but let's go through it gradually. If you get lost anywhere, just let me know. Okay. All right. Let's make another cell to see what our dictionary looks like. It's a dictionary because of the curly bracket. Again, we are looking for this hello string. So again, we start as usual. We start with K1. I'm going to do this one with you in this very cell, one after the other. Okay, let's go. K1. K1, we have a list as the result. That's what we expected. This is the list that is the value of this K1 key. Okay. Now, our list has a couple of elements. It has 1, 2, and 3 elements. Okay. There are 3 elements in that list. So let's look at the first one, 0. That's 1. This 1 is the first element. This 2 is the second one. And then the third element, which is index 2, is this long thing. Okay, so that is the dictionary containing that value. So because this is the dictionary, this is the key, and then again this is the whole value of that. So we're looking for this hello. So we need to extract this key, K2, and we should see this list as our result. Okay, so.
Hello, sir, doctor.
Yes.
Good evening, sir. This is Ebenezer.
Okay.
Sorry, please, I want to ask a question. This dictionary that you're trying to treat using the K1, then and 2, are you using the 2 to index the value to the dictionary, or what? For you to be able to get the value to it, or what exactly did you?
Here, right?
Yes. Was it an index or what?
Okay, let's do it one after the other. So that 2 is the index for this dictionary here.
Okay.
We've already extracted K1, so let's do it like we did the other one, since it may confuse. Okay, so we are looking for. Remember, we are looking for this hello. So we need to be working towards this value. This list has 1, 2, and 3 elements.
Okay.
The third element is this whole list. And we can extract the third element using 2, right? 2 is the third,
Okay.
0, 1, 2.
Okay.
Python starts with indexing at 0. So this 0 is the first item, which is this 1. 1 is the second item, which is, this is the second item. And then the third item is this long dictionary here. Okay.
Okay.
So the next part is to continue going down. Now, this thing here is the value of this K2. So if I extract K2 as well, I should have this list as the result. Okay, and then we keep going down. So our result is a list because we can see it's in square brackets. Our list has how many elements? 1 element and 2 elements separated by this comma. Okay, so let's look at the first element, which is 0. That's not what we're looking for. We're looking for the one here. So the second element, which is 1. So we are going down. Okay. Now the result is in another dictionary that contains this TOF as the key and this list as its value. Okay. So we want to, when we pass this TOF, this key, we expect to get this as our result. So let's do that. So we pass off and we expect to get that as our result. Now, this result here is also a list. It's another list that has 1, 2, and 3 elements. The third element is another list containing the string hello. Okay, so let's keep going down. So how do we get this hello here? We need index 3, which is 2 in Python. Okay, so we pass 2 to get this third element. Just to be sure again, 0 will give us 1, this one here. The second item, 1 will give us 2, and the third item will give us that string. And then finally, this is a list of 1 item. The only item there is a string hello. It has just 1 item, so we can extract that 1 item using index 0. So finally, we pass index 0, which is the first and only item in this list. And we get our hello. So hopefully, most of you were able to get it. If you took some time to go through it.
Yes, it's confusing, kind of, because I'm trying to understand why you still need to reuse DK1 and K2 to fetch for the TOF. Because I was thinking if we had entered the TOF, it should give us the value of 1, 2, then list hello. But I noticed that you went to repeat DK1, list 2, K2, then list 1, then TOF. So I'm kind of like trying to figure it out why do we need to reuse the DK1 without us going to use that TOF, then to be able to fetch?
Reuse this one. Okay, because we are extracting item in a list. Okay, so just like we saw here, remember this this simple example here. Yeah, so this example is a list in a list.
Okay.
We have this list.
Yes.
Item is here. The second item is this 2. The third item is another list.
Okay.
So we need to extract this before we can get to this.
Okay.
Right? So that's what we passed here. We passed this one and extracted this.
Okay.
This result is another list that has 1, 2, 3 items. The first
Okay.
3, the second is 4, the third is this string.
Okay.
Now, this string is the third element the third element in Python is index 2, right?
Yes.
So we pass this second 2 to this original. So I copied this one and pasted here.
Okay.
This is the result of this, and then this
Okay.
additional 2 here helps us to extract this guy.
Okay.
Okay, so that's exactly what we are doing here, but in a more nested fashion, combining lists and dictionaries.
Mm.
Okay, so we did them one after the other. We started from K1, the result of K1.
Okay.
That result, we
Okay.
want the second element.
Okay.
This is the result of that second element.
Okay.
This result again, we want K2,
Okay.
and this is the result of K2.
Okay.
This same
You have
thing,
a list. Okay.
we want the second element or the first index. So we want this one.
Okay.
And then this one, we pass this to get that.
Okay.
Then we get this result. We want, this is another dictionary that has TOF as its key and another list as its value.
Okay.
So we pass that again, and from that result, we want TOF. Right? So this TOF
Okay.
is going to give us that. And
Okay.
then once we have that, we can get the third element, which is this. So the first element of this list is 1, 2, and then the third one is here. So from that result of TOF, we want the second element that gives us this hello. And then finally, this hello is a list of 1 item.
Yes, which is 0.
Which is just this string. And so we pass this 0 to extract it out.
Sorry. Okay. Thank you.
Thank you. Okay. I hope it's clear to everyone.
Thank you, sir.
All right, let's finish up with this, and hopefully we'll have some time to get into our class for the day.
Hope we get this to go so that we can review to be able to
yes.
study it more. Okay.
Okay. Right. So tuples, can you sort a dictionary? Can you sort a dictionary? We can't really sort a dictionary because dictionaries are mappings, not sequence. Okay.
Is what? Mapping?
Yeah. So dictionary is key value per mapping. You can sort a list of 1, 2, 3 like we saw here.
Okay.
But we cannot sort dictionaries. Yeah. So we cannot sort dictionaries because they are mappings and not sequence of numbers or sequences. Okay. Let me put this as a comment. All right, what's the major difference between a tuple and a list? Tuples are immutable, so you can't change the values of a tuple. And we discussed about tuples in class. So for instance, this is a typical tuple T. Okay. You can't really, let's say, yeah. So you can't, tuple objects do not support item assignment. So you can't, they are immutable. You can't change their values. You can't assign high, for instance, to replace these two. Okay. So that's the major difference between a list and a tuple. We saw how we reassigned goodbye this list.
Dr. Arin,
Yes.
please go back to that error message that you just got now when you were trying to assign a list. Yes. Now, that place, I'm seeing type error, traceback, and the bracket of Python input 71. The -8C7FA, is there anywhere somebody can read that to understand what it actually means?
Okay, so this is internal object type error. So this is exactly where the error is stored in memory. Yeah, but this is the actual error message.
Because this message sometimes, right?
Mm-hmm.
There are sometimes I see it and I might not understand what it means fully.
Look out for the actual lettering. Okay, look out for type error and what this is the main thing. Okay.
Okay, so the first one, the one of IPython is for the computer itself. Is the computer
Yes,
that understands?
this is the memory. This is at the memory location of the computer, and this is the message itself telling you why what happened.
Okay.
Exactly.
Okay.
So the tuple does not support item assignment. It's immutable. So that's the main difference. So let's the answer is simply that tuples are immutable. Lists immutable. Oops. Okay. So you can change lists, but you can't change tuples. What is unique? Okay, how do you create a tuple? We've already created a tuple here, so that answers that question. What is unique about the set?
Hello, doctor.
Yes.
Sorry, quick one. I just want to find out.
Yes.
What we are trying to say that we cannot reassign tuple is it means that we cannot index it. Is that what you mean?
Yes, you can't
index it.
You can't assign. You can find out the second, for instance,
okay,
the second value.
Okay.
You can't reassign something. You can't change it.
Okay.
Do you understand?
Okay.
So if you want this 2 here,
yep.
If you wanted to change that 2 to something else,
okay,
like this string, you want to assign this string to replace this value. That's where you get an error.
Okay.
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 All right. So how do you create a tuple? We've just created one, and I'm just repeating that here as the answer. Okay. What is unique about a set? The major thing is that sets don't allow for duplicate items, which I think we covered. Yes, we covered it during the lecture. Also from secondary school set notation and Venn diagram and all that, we know that we can have duplicates in our sets. Okay, so let me just write it here. Sets don't allow for duplicate items. Sets do not allow for duplicate items. Use a set to find the unique values of the list below. So if you have a list, you can actually use a set to extract the unique values, because sets don't have duplicates. So let's see what this lists. So this is our list. We can see that 4 was duplicated, and 2 was also duplicated, 3 was also duplicated, right? If you want a list of, or a set of numbers that don't have that duplicate, you can assign them, you can use a set to actually extract, you can call the set function on that list, and you can get a set of numbers that without the duplicates. Okay. We got a preview. Okay. So these ones are Boolean operations. Some of us have come across these before. We did this also in the class. Equivalence operator. If A is 3 and B is 4, this asks if A is equivalent to B. This asks if A is not equal to B, if A is greater than B, if A is less than B, if A is greater than or equal to B, and if A is less than or unequal to B. Can we mute our mics, please? Okay. Okay. So let me just. So you can get the answers to this by running the cell, but the idea here is simply to engage your understanding of Boolean operators. So 2 is not greater than 3, so we get false. 3 is not less than nor equal to 2. 3 is not equivalent to 2, but 3.0 is equivalent to 3 because they have the same value. So that gives us true. Square root of 4 is not equal to 2. We know that square root of 4 is equal to 2. So to say that it is not equal to is false. Okay. square root of 4, which is 4 raised to power 0.5, is definitely equivalent or equal to 2. So we get false here. Okay, and what is the Boolean output of this cell block? Okay, so let's look at them one after the other. Let's put this in a separate cell. Okay, so let's see what, so L1, is a nested list. It's a list that contains 1, 2, 3 items, where the third item is another list of 3 and 4. And L2 L underscore 2 is a list again that contains 3 items, where the first item is 1, the second one is 2, and the third item is a dictionary that has K1 as its key and the value 4 as its value. So the question is asking, we want to know if first of all, let's see what this value will give us. Let's see what L1, 2 of 0 gives us, first of all. So let's comment out this. So again, you can answer from just looking at it. The third index is 3, 4, and then the first item is 3. That's for L1, so we expect to see 3. Again, look at it closely. We've just done it now. We have 3 items in this list. The third one, or the index 2, is this, and then the first element is this 3. So we have that 3. Let's look at what this gives us. L2, the third element is this dictionary, and the K1 has the value of 4. So we expect to see 4. Okay, so now the question is this greater than this? So let's copy that again. The question we are asked is, this greater than or equal to this? So is 3 greater than or equal to 4? You already know the answer. Okay. So that's it for our assignment. You will get this. So let me rename it to solution. Solutions. And you will get this on the Basecamp, and as well as we will record your marks for your assignment. Okay, questions on the assignment so far? Okay, let's continue. So this is just a quick check. Now, my colleague, Mr. Gaston, will be covering more on some of the other things that we do with Python, okay? Like more details of if, then, else, and I'm sure you've seen some of those things. I will just touch briefly on it, and then we'll move over to our main topic, which is really cleaning and processing of data. From here, we start migrating more into data monging, how data, how you really can reshape, merge, and do all sorts of things to your data as a data scientist. And then going into the machine learning part of it, because we need to understand those basics first. But this is just an intro to some of these concepts. In terms of statements in Python, we have seen that in most other languages we have brackets, like in R, for instance, you have a lot of brackets, and if you write, let's say, an if statement, you have to separate it with these curly brackets. But Python makes use of colon and white space. Okay. So for your if statement now, you don't need to put any brackets between this if and this true. For example, in R, you have to do that. Some other languages as well. So when you write an if for instance, you only need to separate it with this colon, and then once you press enter in any typical Python development environment, like this Jupyter Notebook or Spider or PyCharm, once you press enter, it automatically gives you this indentation, which is used as, so this white space is used as an indentation to describe what takes place in that case statement. So let me type out this one just to show you. So if true, for instance, once you put your colon and press enter, the next cursor starts from here. You can move it backwards, of course, but if you have other codes here, this if statement will not be evaluated because it's looking for things in this indentation section. So it's kind of a little bit, this is also, it's an advantage, it's also a disadvantage in Python, because in R, I can write codes. Let's say you are just doing your prototyping. You can have codes that are everywhere. This one might be here. This one might be here, various things can be in different parts of your script, and it will still work, provided that you close the brackets properly. In Python, if you don't indent properly, you get an error, right? So you can see, let's do it again. This is the correct indentation for this if statement. So when I run it with the correct indentation, it runs. But when I misplace the indentation and run it again, it wouldn't run. And if you look at the error, it actually tells you the error, indentation error, expected an indented block. So it knows that something is here, but it doesn't know how to interpret that unless you tell it that this is where it's supposed to be. And then it will work. So when you start writing longer scripts, you really need to check your code properly. There's just no other way other than to make sure you indent properly. There's no other way to get around it, really. A bigger IDE like PyCharm will try to help you kind of mark out where you're having indentation errors within the IDE, but it's mostly for you to actually sort it out when you are writing codes with, especially with if statements, else, and for loops and all that. We will go more into details in later parts of the course. Okay, so that's it for this. So in language like C++, you have to, like I mentioned, you have to put this bracket and put some things like semicolon to really tell it where to stop and where to start. In Python, we don't need that bracket. You just put a semicolon, and the next indentation should really follow the last value in that order. So the else, for instance, of this if statement needs to be on the same line. So let's look at this example. Our x, we assign it as false. So x is currently false. Now we want to know if x is true, print the number is true, else print the number is false. Now watch exactly how this if and this else are aligned. This if and this else go together. If you have another if and else that does something else within this statement line, let's say you have other things going on here. If you have another if and else within here, you also have to indent them properly. Let's say that if can be here. Let's put an if, and then automatically it actually tells you that the next item should be on this line so that Python will be able to interpret it properly. If you put it elsewhere, you will get an error. Okay. So that's one. Oops. That's one interesting caveat in Python. So you are writing a code, excuse me, and your else mistakenly jumped to this place. You will get an error automatically. And sometimes you may not, if you have a very long script and somebody has mistakenly touched the tab key. Let's say this is your script file and you're about to save it. Somewhere, somehow, your finger touched the tab key here and you saved it and you wanted to run it on a server and you're getting errors. You will have to debug your code line by line to actually find out what is going on. Okay. Branches in if statement. So this was the part I was coming to. So let's say we have this string tcrt assigned to location. So we can ask if location is this, print that, else if. So in Python, it is just else elif. I think many other languages use that. So else if location is this, print that, else print something. So that's the format that it follows. So if else. So basically what this is saying is, if the first statement is not true, evaluate the next one. If the next one is not true, then you can have as many else ifs in the statement as possible, but you need to close off with only one else, the final else. So if you're comparing 10 things, so something that might be in your assignment is grade. If grade is A, print excellent. If grade is B, print average or something. If grade is C, print good. If grade is F, print fail. Else, print what is your grade, or enter the correct grade, something like that. So it may be a simple assignment for you. You just use else if statement to print out various things. Again, the indentation is the major thing within Python. Once you miss where the indentation is supposed to be, it will not be interpreted correctly. Okay. Moving on. So again, like this example here, just similar to the last one. If someone's name is Arinze, print welcome else, print that. So if you change something, if that string was obviously different, then the next statement is automatically evaluated because this first statement is not true. They are not, this and this are not equal. Okay, so we use if statement to also capture errors, but when you come to the section of errors, there are other things to use in capturing errors, like try catch. Okay. Yes, another final example. If someone's name is Bill, print welcome Bill, else if the name is Gaston, print Gaston, else print what is your name. So it's looking for this, and so this is the section where the statement is true because the person variable has the string Gaston as its object, so it's correctly evaluated. So just a quick one on for loops. Like I said, in other classes, we would cover all this in more detail. We want to start going more into the data aspects and the things that are needed for machine learning. But for loops, definitely you write loops within your machine learning scripts. So in Python, for loop acts as an iterator. It loops over things. It goes through an item that are in sequence. So things like strings and lists and tuples can be iterated over. Okay. So for something, do something. So for instance, in this list here, I think in this list, we have a list of 1 to 12, and we just want to display and print out each element line by line. So you can use an iterator. So this iterator num can be anything. So let me just put it as a comment here. Num can be anything. Okay, so it mustn't be num. Yeah, so I can put, provided that you put, so for you can put I here, provided that you print out that I, you get the same result. So num iterator can be anything. Okay. So, but basically what this is saying is this for loop will take an iterator value and go in that list. So it's going to go 1, 2, 3, and then for each one, it's going to print out, it's going to execute this print statement. And that's exactly how it works. Now, again, as you can notice, this print is properly indented. So if you move that print here, you will get an error. So it has to be properly indented, at least to within, just somewhere within, let's see. Okay. Somewhere just after the colon. But if it's anywhere on the same line with the for statement, an error is printed out. So for loops can help us to do a lot of things, and we'll be seeing more of it in later lectures. But if someone had a task of just getting even numbers, you can use a for loop to extract even numbers from this list. What is an even number? An even number is number that when you divide, when divided by 2, the remainder is 0. That's an even number. So that's what this is saying, and we covered this in our previous class. This is modulo. This is an example of where it's very, very useful. A number divided by the remainder, if the remainder of the number divided by 2 is 0, then that number is an even number. So we have a for loop to initiate our iterator. For each item in that list, we want to check if that number divided by 2, if the remainder is 0. And if the remainder is 0, print out that number. So this is just doing one job. But we can also use the else to do something else. So we've only told it to do one thing, and it just does that thing. We can tell it to do something else after this if statement. Okay, so if the remainder is not equal to 0, then you can do something else. So that's where this else comes in. So there are the odd numbers, their remainder are not 0, so it prints out odd for that line. So the first number is 1, there's an odd number. 2.
Hello, doctor.
Yes.
Sorry, for this line of coding, is it static like this for even numbers, or if we pass if num percent to equal 0, that if we use modulo, will it still pass?
For odd number?
I mean for even number.
So we're using this to detect even numbers.
Yeah, is that particular line? I mean, if we use modulo for that percent 2 for the remainder to be 0, will it go through instead of putting 1%? If we use percent.
Okay, that's not modulo now. So modulo is this single percent.
Okay. Okay, or could it be in R that they use modulo twice, that they use that percent twice?
I think so.
Okay, never mind then. I was thinking it's the same with Python also, that percent for modulo, yeah.
Yeah, so I think, is it? Yeah, but in Python it's just one single.
Okay.
Yeah. Okay. So we can use this to print out odd numbers. And then we can simply sum this our list by just adding nothing to it. So for instance, if you have, if we instantiate something to be 0, you can be adding that 0 to each value of the list and reassigning it to this value. So you're basically accumulating the values of that list. So this is our list now. If you add all these numbers together, you're supposed to get 78. So one way of just using for loop to achieve that is we can have a starter variable, which we call 0. And basically, you are adding 0, starting from the first one, we're adding 0 to each element of our iterator and reassigning it to our list sum. And we're just printing, reassigning it at the end of the day. We have our summed up list. So let's print so we can see what is going on here. Let me comment on this one. Okay, so just to clarify, now that I've put the print statement as a part of the for loop, the first item is 1 because 0 plus 1 is still 1. So this is our first variable here. So the second one you add, so and then we assign the result to this our list sum. So for this first part of the loop, this value is 1. Now the next iteration, at the next iteration, our number is added to that list sum, which is this 1, and reassigned to list sum, and then we print it out. So the next number there is 2. So 2 is added to 1, which results in 3, and we print out that 3. And 3 becomes the current value of list sum. At the next iteration, 3 is added to, let me copy this one. 3 is added to, this is our list here. 3 is added to 3 and reassigned. So 3 is added to 3, which is 6, and then it's reassigned to list sum. At the next iteration, 4 is added to that 6 and reassigned. So that 4 plus 6 is 10. The current value becomes 10. 5 is added to that current value, 15. 6 is added, 7 is added until the last element, which is this 12. So the last element is, when the last element is added, it prints that out as well. So our final value becomes 78. But we can see how the process goes on internally. Okay. So let's see how far we can get on this, and then I think we'll continue from there tomorrow, and we'll also get to do some assignments. So last week we saw some data, at least. You saw some data in Iris. You saw how data can be imported and loaded and all that stuff. So we're continuing from there to actually see other more detailed tasks of what can take place. Now, you can either import that data as CSV, or you can also generate data within Python for exemplary purposes, just to make an example. So the data comes in as data frame with pandas, but you can also create data frames from lists, from series, from anything. You can actually create data frame from a list like this. Okay, so let's look at some of the things that we can do. A lot of time is taken up in a typical data science or machine learning process in data pre-processing. So sometimes you have data in XML, sometimes you have it in CSV, TXT, even PDF, all sorts of formats, Excel, JSON, and all sorts of formats. And not only that, you also have various things. Let's say things might be missing in the data. So there are many ways that we can deal with those kinds of issues. Within Python Pandas, so Pandas has become the de facto library, as it were, for data analysis and data manipulation in Python. It was not there before. This library was not there before until somebody took the pain to start creating it and coming up with functions that can make our lives easier using Python for this kind of tasks. And it's built on top of the NumPy library, which is really a good floating point mathematical library that's for array computation mainly. So it tries to be as fast as possible and tries to run quite quickly because of the internal C bindings that it has. Okay. So in terms of pandas, we can, so the first point to know is that floating point values, we can represent floating point values NaN in pandas as missing data. So we use the NaN to represent missing data in Python. They can be easily detected. So you can easily see the value. You can easily see the value. You can see it stand out, basically. So the Sentinel value is basically something that stands out from the rest. You can just see it here, for instance. NaN is just completely different from all these other ones. So here we're just creating a pandas series. And we have strings, but most importantly, we have numpy.nan. So using the numpy library, that's what we use to create this NaN value. And you can check whether the value is null. So NaNs are null values. They are not a number. So something that just doesn't exist. Okay, they are different from. It's different from zero, for instance. Because zero is something, but this one is not a number. That's what that's the implication. So you can check from this. So if we run this, you can check if it is null, and the one that returns true is this third item, that NaN is actually a null value. So in R, yes?
Sorry, is null, from my own experience on SQL, is null usually means that when a value is empty. So is it another reference here?
Yes, so
Or-
this is not available. Yes, so it's kind of empty. There's nothing there.
Okay, so
Nothing there. It kind of conforms to what we see all the time in R. So in R, we can see NAs for missing data, which means something that was not recorded. If I was collecting the age of everybody and somebody refused to give me their age, I'll put NA in that Excel sheet or whatever I'm using to collect the data. So when cleaning up data, there are various things to take into account. We can assign none. So basically, this not by default, Python has none value. Before Pandas was created, Python had a way of representing that something doesn't exist. Before somebody thought it wise to develop the Pandas library a couple of years ago. So this is just to show that the default Python non-value is the same with Pandas NaN value. They represent the same thing. So we can call the is null function. So now here I'm just assigning none to the first one, this one. And then when I call this is null function, I now have that both the NaN and the none, both of them are null because they return true as results for us. So again, in your data frame, in your Excel sheet or CSV file and all that, there will definitely be a lot of NAs and missing values. So what do you do when you come across these kind of things? One way is to drop those missing values if that justifies your type of analysis. But in most cases within machine learning, you may want to do something else. But it is possible to drop that NA value. It is also possible to fill that missing value using forward fill or backward fill. We'll see some examples if we have the time. We've already seen is null, which returns Boolean that indicates where a number is missing or not available. And there's also a function called not null, which is simply the negation of is null. Okay, so we can import NaN as NA, and we can just generate a Pandas series, for example. Here, we just want to test dropping NA. Okay, so we have some NAs. We have 1 and 2. And when we call the drop NA, now I would like us to get used to more basically looking at the documentations as much as possible. So what have I done? I have my data, Pandas series, yeah, and I have the data, and I press dot. I can see the various methods that can be called on that series object. Okay, so the one of interest now is the drop NA. So you can see it here, drop NA. When you put your bracket and do your shift tab, you can see more information about what you can do with that function. Okay, so by default the axis is 0, which means rows, but we can also change it to 1 for column. In place is false, which means it's going to return another object after performing the operation. But if you want it to retain the object type, you change in place to true. Okay. So when we call the drop NA on that, it takes off our NA values automatically. And we can also select the not null values. We can subset, just like we saw in our list subsetting or indexing. We can subset the things that are not null. So when we subset the ones that are not null, then we have that as our result. So kind of two ways of accomplishing the same thing. So pandas, you can create data frame. You saw data frame last week. Either you import it from a CSV file or something. But they are kind of a bit more complex in terms of how you drop rows and how you drop columns and all that, because by default the drop NA will drop rows, so you need to pass more things, more arguments for what exactly you want, because by default this drop NA. So let's make a data frame. Our data frame, the first row is this 1, 6.5, and 3. The second row is 1, NA, NA. Third row is NA, 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 and the fourth row is NA, 6.5, and 3. So obviously, if you just put 3 points, Python would complete it for you in floating point, complete 3.0. So this is typical data, and what we have immediately when we call drop NA. So if we take off all the NA values and we call it cleaned, let's see what cleaned looks like. So these are the clean parts of it, and